Good morning, everyone. Um, my name is Viking Christensen. I'm the VP of Sales Engineering and Partner Development with Global Drain Technologies and Food Safe Drains. We are thrilled to have you join us for today's session, Introduction to Clean in Place Systems. Before we dive into the technical details, I'd like to introduce our panel of experts who bring a wealth of experience from across the industry. Joining us today are Craig Gustafson from Craft Automation, Jason Tucker representing JBT Morel, and Eric Kurtelak from Madison Chemical Company. Together, we'll be exploring the critical role that automated cleaning plays in modern production. What is a CIP system? To ensure we're all on the same page, what exactly is a CIP or clean in place system? Essentially, it is an automated method used in the food and beverage and pharmaceutical sectors to clean the interior surfaces of pipes, tanks, and equipment without the need for disassembly. While a basic system typically follows a three-step process, pre-rinse, chemical wash, and final rinse, more complex operations might include acid washes or intermediate rinses. Because the scale varies so much, you'll see these systems priced anywhere from under $30,000 for small scale producers to multi-million dollar investments for large scale beverage manufacturers. Cornerstones of modern industrial processing. Why is CIP considered a cornerstone of modern processing? It comes down to four key drivers. First, repeatable hygiene. We are moving past the looks clean era into the era of strict verification and validation. Second is operational efficiency. By reducing time to clean, we directly increase your throughput. Third is safety and sustainability. We want to remove workers from exposure to high temperatures, harsh chemicals, while simultaneously optimizing our water and chemical footprints. Finally, there is a data capture. In today's regulatory environment, having a digital record of exactly how and when you cleaned is no longer a luxury, it's a necessity. Today, we're going to walk you through the life cycle of a CIP strategy. We'll start by defining your scope and soil types because you can't clean what you don't understand. We will then look at four pillars of cleaning: time, action, chemical, and temperature. We'll also discuss frequency, how often do you really need to clean, and explore how modern instrumentation and automation can drive sustainability. To wrap up, we'll cover the logistics of managing the return, ensuring the entire loop is as efficient as the process it supports. To get started on these technical fundamentals, I'm going to hand things over to Craig Gustafson. Craig, the floor is yours.
Okay, thanks, Viking. Good morning, everybody. How are you? Welcome to the webinar. The way myself and Viking, Eric, and Jason set up this, it's a panel discussion. So what we thought might work best for the sake of this is giving one or two slides from each of us. I'll explain kind of how we designed that, and then leaving a bunch of time at the end to be able to field questions, talk about that in a traditional, panel approach to things. So, Viking, if you go to the next slide, please. What we thought was kind of a good icebreaker for those that are attending this. So just so everybody has a little bit of perspective on this, I was looking at the list of attendees a couple days ago, and we have all of you represent, we had a question that put you in either advanced understanding of CIP, intermediate, or beginners. And just to give you some perspective on that, we have about 25% beginners, 25% advanced, and about 50% is intermediate. So knowing that we have a pretty broad range of people on this call, there's some things that you may already know, others that you may not. We may get into a little bit more detail for those that are more advanced on this, but we thought that this was the good starting point to get us all on the same page. And then if we want to get into more detail in another webinar, when you guys give some feedback to this, you can provide that to Jennifer and the folks at FPSA, and we can address that then. So to kick off CIP in general, why it matters more than ever, and Viking addressed some of these things, but we see growth in the category. So all of us on the panel interact with CIP. It's not the only thing we do, but all of us have been seeing a lot of growth in that area, whether it's an OEM and a mechanical, or on the control side, chemical side, or whether you're a direct manufacturer. More and more people are gaining interest in this and putting them in place. That's been driven by food and food safety and contamination risk, just more concern with that in general, across multiple industries, not just one or two. That's been increasing the interest. And then we know from an audit and regulatory compliance perspective. So there's what I call the table stakes or baseline, which is the FDA, but many of us also interact with SQF and BRC, which obviously are have a little bit more stricter audits related to those. Those of you that know, SQF tends to be a little bit more contamination, food safety. BRC, which is an international standard, is a little more about quality and consistency in terms of what they put a company through for an audit. Other areas of concern, production downtime costs. So those of you that maybe have a little less sophisticated CIP, or perhaps even using manual, by going to a more automated process, that can increase the, how quickly you come back to your production time. So you're gaining efficiencies from that perspective. A lot of companies have told us they have more frequent changeover. So as consumers and marketers get more concerned about segmentation and product SKUs and things like that, that we all have to manufacture and put in place, those frequent changeovers mean we have to clean faster and get those in place, that we're still following all the regulatory pieces that we need to. Obviously, we know inflation's been going on all over the world, but water, chemical, energy costs have been going up, up, up. And so is there a way that CIP can be designed and implemented that reduces that? And then, of course, the last piece was just the almighty labor shortages. That comes and goes in cycles like anything we experience. But not only is there a shortage, but I would say when you look at CIP, the other thing it does for an organization is it tends to build morale and enthusiasm, because the operators will actually have something, a playbook that they can follow and make sure they're following all the things that the quality assurance department or people are asking them to do. At Craft Automation, I looked at a few different folks that we've done CIP systems with, and this is the bottom right-hand box there. We see that many plants lose somewhere around 3,000 to 10,000 per cleaning due to inefficient CIP. So whether it's just taking too long, using too many chemicals, they have different labor that's not trained, etc. So you can imagine, if I just take the midpoint, that's about 1.5 million in lost productivity each year. And we try to size that a little bit. At Craft, since we're on the control side, we also try to show things like ROI, etc. So that's just to get us started. Like I said, for the first couple minutes, we're going to talk at you folks a little bit, and then hopefully we get a dialogue going. I'm going to hand the baton over to Jason. We're going to go with mechanicals first, chemicals second, and then back to controls third, and then we'll come back for questions and things like that. So Jason, all yours.
Thank you very much, Craig. So as you saw in the first couple of slides when Viking was speaking, he talked about 4 pillars. And really, when you talk about cleaning anything, whether you're washing, your dinner plate, you're washing your hands or washing your equipment, you could break it down to that sort of mindset of what are the inputs. There's some kind of a mechanical action, the scrubbing effect. There's the temperature input of how warm I'm getting this. There's the chemistry, so the detergent or soap I'm using, and then how long I'm doing that for. And I can really break down cleaning into those 4 key elements. If I fixate on the first 2, those are especially the mechanical equipment, the inputs that they give to a system for cleaning. So that's often your clean in place system if it's centralized. And the way we look at that for the sort of scrubbing action, when we talk about lines, which is what this chart's representing. So these are common, this is like sanitary tubing sizes, and you see the chart as it goes across, it's hitting a certain velocity through the line. And that's how we often break this down, is if I can go at least that velocity or higher, it's setting the level of turbulence. And that's the point where it's going so fast in the pipe that it starts to trip over itself. It's actually tumbling, and then that's what's actually scrubbing the inside of this pipe. And the most common basis we usually see is about 5 feet per second, which is the far left column, or it's just under 1.5 meters per second for frame of reference. That's usually our baseline. What we'll actually see, I see there's a mistake on the chart. I apologize, but as it goes to the right, that should be 7 feet per second as we go for the middle section, and then 10 feet per second is typically kind of the high end. At that point, that's not so much a target, but that's actually what we're going to look at, kind of the high end of the question of efficiency. That's when it's enclosed in an actual line, so pipe and tubing. If I can go to the next slide, please. So when we're talking about a more open surface, so this is inside of tanks and vessels, or perhaps, some kind of a conveyor, or anything that's open that I'm not completely flooding, we start to look at this in a different direction. Now we're actually looking at a spray. So this is your thumb going over the end of the garden hose where I'm getting this blast of jet, and that impingement that's actually hitting a surface, that's what I'm using to clean at this point. And so when we look at things for vessels, we'll look at like the placement of the nozzle, and how that's actually going to spray out and hit the different surfaces, and then cascade and run down like a waterfall around the different areas. And part of the mindset on that is really looking at it as if I was shining a light. We'll talk about like shadowing. So if I were to shine a spotlight from the point where the spray is coming in, wherever I would have a shadow blocking it against the wall, is something that wouldn't get clean. So I have to actually think about adding more spray balls or moving them into different areas so that I can kind of hit around corners to get all these surfaces. And then beyond that, we look at the flow that we're having, the restriction, so how much pressure and for it to give that actual force to hit things. That's really that mechanical action piece. The other piece I mentioned is, temperature. That's a simpler input. So that could be electric heater. Often it's a heat exchanger. So using like steam or hot water to elevate the temperature so I can input that energy to aid in the cleaning process. And then the next piece we talk about is really the chemistry, the detergent. And for that piece, I'm going to hand it off to Eric so he can speak to that.
Thank you, Jason. So when we really look at a CIP need, we need to consider the different soil profiles. And in a very broad way, we can look at the soils present in the food environment and break them down into organics and inorganics. So your organics are going to be your protein-based soils, sugars and carbohydrates, and your insoluble organics. And when you get into those organic materials that are compounded and built up onto the surfaces of the equipment, in those cases, you really want to use alkaline detergents. Okay. Now, when you look at the inorganics, things like your iron-based soils, your minerals, silica, additives, and stabilizers are often inorganic. When you look at those types of materials building up onto surfaces, you really want to lean towards your acids in terms of the chemistry selection for that challenge. So there are things to really consider, particularly if you look at like proteinaceous soils. You have to ask, does your product have plant proteins? Does it have animal proteins? Does it have both? How readily do each of these types of proteins bind to carbohydrates to create those glycoproteins? And so you're going to think, okay, if I have a plant-based product, there's a higher likelihood that I'm going to have to deal with glycoproteins. And so how do I break those down? And so thinking about the specific chemistry in your product offering, thinking about the process parameters and how it promotes different bond realities and how do you overcome that through your cleaning, it's really quite important. Thinking about something like carbohydrates, sugars have very different linkages as compared to fiber, as compared to starch. And so we're looking at these different carbohydrates and saying, to what extent is each present in your food product? And so how does the buildup change in your lines over time? Again, you have the idea of glycosidic bonds, where you have sugars bound to lipids, and how do you overcome that? So just really thinking through the chemistry and the detergent selection is quite critical. And then, of course, you have to think about the surface condition. What's happening on the surface of the equipment, on the surface of the pipe? How is your passive layer? Are there areas that are non-stainless? Something like the interior of a microwave tube. You've got to treat that in a recirculating system. And so we have to think about the material of construction of the equipment and how that interacts with the chemistry, as well as the actual soil profiles. So those are pretty important considerations when you're designing a system. I think we can move on to the next slide here, talking a little bit more about tact. I mean, really, we want to be cognizant about the CIP time and how that's going to really change depending on the length of the circuit, the velocity of the solution. So how fast are we pumping the fluid through the system? How large and comprehensive is the system? And different systems and different circuits will require different flush out time, wash time, and rinse times, and that can all be done by design. And certainly, time becomes a consideration when you have something that hasn't been regularly cleaned and you have to recover it back to a bare metal state, to a fresh condition. So your routine cleaning time will be different than your recovery cleaning time. Action, again, you want to have your velocity correct for turbulence. You don't want to get into laminar flow profiles or any kind of the transitional profiles. You want to have full turbulence all the time. That is the most critical component for the scrubbing action and getting the efficacy of the actual fluid interactions with the food components. Concentrations, in your routine cleaning, your concentrations can be relatively low. I mean, you look at an alkaline recirculating CIP, it can be, 0.5% to 1% by volume. Now, that's not going to apply in every single circumstance and every single soil load, but, for the most part, you can have pretty low concentrations in your alkaline CIP. Acids can actually be lower, 0.25% to maybe 1% by volume. So it's really not a huge ask in terms of the chemistry and the chemical inputs to do this effectively, as long as you're consistently keeping the buildup out and you're doing your cleaning in accordance with your master sanitation schedule and your SSOPs. Certainly, when you talk about recirculating sanitizers, sanitizer concentrations are defined by the label, and you have to follow the EPA registered label. And there's really no discussion on that point. They define this is where the efficacy is, follow the rules, and you'll be all right. Okay. Temperature is really interesting. You want to flush out using your warm or to hot water. Wash temperatures range. They could be 130 to 170 Fahrenheit in most cases. And rinse temperatures are going to be ambient to warm. Sanitizing is best done with cold temperatures. Okay. So you want to have colder water, ambient to cold. And when you think about that, well, controlling the temperature in order to melt the fats that are involved, activate the chemicals, help to dislodge and dissolve food materials, all these things are important, but you can run into a lot of problems if you push your temperatures too high. And so there's an important balance point. And really, with all of the tact elements, there is a balance point. Your time, action, concentration, and temperature, they're all going to be non-zero quantities. Okay, you're not going to get away from having to have some presence of all four pillars, but you can adjust them. You can create trade-offs for optimizations and cost-saving opportunities. So really, when you plan a CIP system, you keep these four elements in mind and say, okay, how important is it to save time and get back into run status? How important is it, to reduce chemical concentrations? How important is it to control temperatures? Thinking about how the trade-offs and inner workings of tact really can progress your business, that's a really important conversation, particularly at the install and the front end of a new CIP system. Let's move on to the next slide. So in the next slide, we're looking at sanitizers. And so now we've said, okay, we've got the correct chemistry. We've got the detergents that we need. We've handled the soils. We had the right cleaning action. We had the right, amount of flush time. We had the right amount of, of heat. So we've handled all of those pieces. And now we feel that the system's clean, right? But we need to sanitize. Sanitizers are going to broadly break into two categories. You're going to have your oxidizing sanitizers. These are going to be, also called non-residuals. These are going to be your chlorine, peracetic acid. They're going to kill things very, very quickly. They don't last as long. Okay. Then you're going to have other sanitizers that are residual sanitizers, and residual sanitizers, they keep that bacterial inactivation going for extended amounts of time, maybe an entire weekend. Very, very widely used is going to be your quaternary ammonia. Quat is a very, very well-known residual sanitizer. Acid anionic sanitizers have a good residual effect, and I guess traditionally there are uses for iodine. So iodine is an effective sanitizer that stays around quite a long time. So those are the main points that we want to look at with chemistry in terms of kicking off the conversation. But I think for some additional insight, I'm going to turn to Craig and let you take it from here.
Very good. Thanks, Eric. Yeah, so for the last three slides here, and then we'll turn it over to questions and discussions. Jason kind of walked you through the mechanicals. Obviously, Eric just went through some high-level information on chemicals. At Craft Automation, we do process control systems integration, so we're primarily engineers. The three slides I wanted to share to kind of give some background on this. Often we're working with OEMs and direct manufacturers, and sometimes, like with the OEMs, we're asked to come in and help design or put together the P&IDs, which is the piping and instrumentation design for a given system or modify something. Often during that discovery process, these are questions that we'll bring in and ask people. I'm saying, how healthy is your CIP system? And depending on the sophistication or complexity of your manufacturing and the industry that you operate in, some of these may be applicable, some may not. So, I'm just going to read a couple of them. And the idea behind this, if you answer no to these, that's where you want to think a little bit more. Do I need to go deeper on my CIP system? Or if you're just bringing one in, are these areas that you want to integrate or include or not? So, for example, do you have automated cycles for production lines, cleaning steps consistent every time? Do you monitor temperature flow, chemical concentration? Are cycles logged and auditable depending on what your needs are for quality assurance? Is it integrated with production control so that there's alarm systems built in from a safety and from a efficiency perspective? Do you know the true cost of a cleaning cycle? So when you're looking at chemical, water, labor, utilities, electricity, et cetera, do you have a feel for that? Do you know what it might be? Do you need more information to get an ROI on a given investment? Or could the cycles be shortened to give you more production time, et cetera? So those are just some questions to ask yourself as you're thinking about your organization, what you're trying to accomplish, depending on where you are on the spectrum of CIP. Some ways to get you thinking about the business. Viking, if you mind clicking to the next one. On the left here, so when you get into the world of controls and processes, systems integration, et cetera, and I guess I should mention, just so that we're all working off the same vernacular here, when I say PLC, that means that's the piece, the program that's actually running the CIP equipment and how much dosing should occur with chemicals and water, et cetera. The HMI is what the operator is using. Typically in the controls area, they'll have like an iPad, like most of you know this already, type device where you can program it, tell it what to do. And then the SCADA, which is important for reporting and transparency and kind of what I would call supervisory inputs that are needed. When we get into root causes of issues, what we often get called in about is things you see on the left here. So if there's a lot of manual steps in your current CIP process, can that be solved with PLC sequencing? Often where we're brought in to see how much effort you want to put against that, depending on how complex your manufacturing and your CIP is. Are there inconsistent variables? Do you have the right level of sensors, and how do they work? Do you have logging, and are you getting the logging you need to meet your BRC, SQF quality assurance folks? Might you be over cleaning so that you're not getting the ROI you need, so you're using too much time, energy, utilities, chemicals, etc.? And then is it being integrated so that everything is kind of including the SCADA, so that your supervisors are seeing the same information that your operators are seeing? Typically, that's what your controls are going to bring in to the picture from a CIP perspective. And then the last slide, Viking, please. Just what we tend to follow, and I'll just hit these pretty quickly. CIP design principles, what we think to, and again, this is from the lens of a controls group, us. So do you have standardized CIP recipes or playbooks that your operators are following, so that it's repeatable and you're ready for what those potential audits could be? Have you, or can you separate the utilities, water, chemicals, etc., not only for reliability, but for tracking on costs and things like that? The code itself, when we like to get involved, is it modular and reusable? Because your business may grow or decline, decrease, etc., or you may just change with different SKUs that you want to do. So you want some flexibility from that perspective. Skid-based panels is where we like to put it on with the CIP units, because it just makes it easier for the maintenance people to get to it. Or if we got to rotate something out if there's a big issue, etc. Keeping in mind that these things do need to be serviced and accessible. So is that built into your design when you're doing it, and where it's going to be located within your plant? Typically, remote diagnostics depends how sophisticated you are, again, but that's where you can get faster troubleshooting and you can get the right people involved if there is an issue and you don't want to lose downtime in your manufacturing. And then the last thing we typically ask about and try to do before we give our quotes and our bids is just what's the expectation if you think the next 3 to 5 years for expansion or line changes, or how much flexibility you need. Those are the types of things that we like to ask as we're working with the chemical, the OEM providers, the direct manufacturer, etc. So the goal there, as I mentioned, was to try to, for each of us, to give you a little bit about what we do as it relates to CIP, from mechanicals to chemical to controls. At this point, I'm going to hand the ball back over to Viking and see if there's any questions. We wanted to take the first 20 or 30 minutes kind of giving you that background, and then get into panel questions and what that might look like. Viking?
Yeah, that was terrific.
I was peeking ahead, Viking, here, and I see there is a question in there. It's kind of related to the topic that I was speaking to, if it's okay.
Yeah, why don't we read the question?
Sure.
So, by the way, Craig, Eric, Jason, that was awesome. Thank you so much. Hugely insightful. So, again, if you do have questions, there is a chat. Please feel free to text in your questions. We do have a few. There's a question on the action component where it's noted turbulent flow can help improve cleaning as one of the 4 components. If you're cleaning larger equipment, tanks, or other, I'm assuming the cascading of the CIP liquids would not be turbulent. Are there tools or methods to provide this turbulent effect? What is your experience on jets rotating or fixed spraying patterns? What are your recommendations?
Okay, so a few pieces on that. One, the first question is when we're cascading out in a spray, assuming that's not turbulent, you are correct. We usually distinguish the difference between inline and that open spray, of like how we're actually putting that action, that mechanical piece. So when it's flooded and closed in a tube, that's when we're really talking about turbulent, because normal kind of peaceful laminar level flow that's going through there. Not looking at that as being aggressive enough, so we're at least hitting the mathematical point where it should be jostling around, as I mentioned in the line, and that's where I'm cleaning. In the open area where I'm actually spraying over, yeah, I look at either impingement or cascade. Impingement is it's directly in the path of that spray. I'm going to hit it with it to try to knock it off the wall, or I'm just simply from that piece flushing down to hit to the next area, and that's the cascade. And so this goes back to it depends on your application. I look at it. Sometimes it's a mixing system and the area we're talking about is below liquid level, there isn't a heavy deposit on the wall, simply the cascade and the flush off is going to actually get it clean. I don't need that level of turbulence. If it's a more open, like I think of like a spray dryer chamber or something, or areas I've worked in where I can have something dried and caked on, I need a more direct blast to actually hit that, and I'll position nozzles to actually hit that kind of surface. So it's a difference on the application. And your last question on the rotating jets on it, we use them both for different applications. What we'll often see for the mechanical rotating ones is often I have to generate higher pressure with lower flow is often a reason that they're directed. That's one of the main reasons. The other reasons is something you touched on is that direct impingement. There are styles that are actually more designed to give more angles to actually have that direct focus jet coming around in different areas to hit it. So you can have a couple different reasons of why you might want to use the mechanical. Otherwise, the simple static, when I can just create enough flush where I'm going to go over there, it's a much simpler technology. So a fewer mechanical pieces, less chance of failure, a lower cost to put it in place. So that's why it's often a first choice. And then the mechanical is when I have that more specialty application.
Great. It's awesome. We've got some other questions rolling in. What is the velocity that turbulent flow is certain? Does the velocity change depending on the diameter of pipe?
The target velocity that we hit, we mentioned the 5 feet per second that's the traditional practice, and that's what's been put in for like especially the spoilable products from the USDA side of like milk and eggs and that type of thing. That's a minimum threshold that they try to hit. And that was, again, I feel like that was more the mathematical model as far as it wasn't tested in a lab to confirm that this is that hit point on it. It's been reinforced by continual use and swabbing that this is getting it clean. And we picked that 5 feet. The velocity doesn't change, your volumetric flow changes. So like that was what that table I was putting up there was, is you'll notice as you click through the different diameters on it, I have a completely different, GPM flow, but I'm still trying to hit 5 feet per second on that same level. So as long as I can hit the velocity, that's my edge of the turbulence.
Great. Thank you. So I've got a question here. Can I CIP anything, or are some things just not able to be cleaned in place?
Well, there are certainly a lot of systems that are not conducive to CIP. Sometimes you're going to have recirculating cleaning where it's not a true CIP because it's a hybrid system with some open surface cleaning. Other things are just going to be open surface cleaning. So there are a lot of equipment that are present in food manufacturing environments. Even if you were to think something simple like a conveyor, it's a food contact conveyor. How are we going to CIP that? You can have a spray bar over it, right? But there are a lot of different things that you're going to have to get in terms of the drive and the sprockets and kind of those axles. There are things that need individualized attention in the framework, and so there are always going to be areas that are more conducive to open surface cleaning, be that open surface wet or open surface dry. But as much as possible, you want to lean, I think, towards the CIP because of all the optimizations that are available through, you can control your data capture, your repeatability, the consistency of chemical usage, certainly the labor component. There are all kinds of different things that you can control by leaning towards CIP, but bear in mind that those results are only as strong as the sensors. So making sure that you have the right sensors, the right calibrations, and you're getting good, strong data that you can rely upon. And so, yeah, there are some things that are not so conducive to CIP, but we do encourage to use CIP insofar as you can.
Great. Is it fair to say that the more complex a piece of equipment is, the harder it is to CIP?
Well, that's an interesting comment because you can have very large, complex pasteurization systems that are fully CIP capable, right? And so they're designed to handle CIP. So when you think about like moving internal parts, so like with scrape surface evaporators and things like that, they're harder to get into some of the nooks and crannies, right? Things that are more prone to disassemble, right? You have to disassemble to get it the pieces. Um, there are certainly some equipment that have so many mechanical pieces inside and so many hidden areas that you've got to take them apart and clean them and then reassemble them after sanitizing. But yeah, I would not say that the scale or the complexity of the system automatically disqualifies it from CIP. It's more the particular design elements where you're not going to get the impingement, where you're not going to get the turbulence, where you're not going to have the complete coverage that you need to rely on for that scrubbing action.
Perfect. Thank you.
I think that's Jason. Do you have anything to add there?
Yeah, from the equipment side is yes, if it was initially designed with the intent that it would be CIP'd, I feel like that you have a chance to do it, just to what Eric was saying. Like even if it's convoluted and complex, if that initial design, I had it planned in that we'll do this by spray balls, we'll do this by flush out, it's made to disassemble. When they have that kind of thought in the process, it can be cleaned. It's much harder when it's retroactive. We have something existing that was never meant to be CIP. Can we make this CIP? That's a much bigger ask.
The other thing I'd add in on that is, like, for example, last week I was giving a quote on a dairy company that was looking for some CIP help. They hadn't even picked their mechanical partner yet. They came to us first on the control side because they had some specific needs they wanted to understand better in terms of pasteurized milk ordinance and batching and how that was going to be reported on. So the scale of it didn't really get us nervous at all because typically, as long as whether it's me, Jason, or Eric, we're understanding what's being asked of us, the scale typically doesn't intimidate us in terms of getting a solution built. We just really have to listen to what it is, and sometimes it takes an on-site visit if there's any type of, not sometimes, usually it takes an on-site visit for us to design something that's going to fit exactly what you're looking for.
Great. Thanks, guys. I've got a question here. Do you often find that operating parameters and set points have drifted away from original targets over time, and that this is a leading cause of cleaning issues?
I think over time there's often drift for an application. Most processes, even by like recipe changes or needs to the plant. I've yet to be called to a plant to say, hey, could you slow this thing down? I'm making too much money. Everybody wants to run faster, push it to that next level. And so there's constant drift to the change. And that's just the nature of like the business change. The equipment itself over age, it will wear, it will come into use, and you have to maintain, you have to keep up on seals, you have to bring instruments back into calibration, you have to take care of the system continually. So it's absolutely a factor. It's how much care you put into it.
Well, and that also brings up the whole conversation of validation. If you are running an operation that is existing in a validated state, then you're not going to be making changes to your CIP. You're not going to change the circuit. You're not going to change, the residence time. You're not going to change, the flow rates or anything that is strictly defined in that validated system. If you make a change, you're no longer validated, and you have to go through that process again. So these changes have to be governed. There has to be a change management system, and there has to be a review, verification to just confirm that everything is happening according to plan. That's great. Okay, we confirmed that this is the plan and we followed the plan, but that's not validation. And so when you have something that is validated and you are operating in that manner, you're not going to see that drift to nearly the same extent.
Great. Thank you. Do you have any comment when comparing types of CIP systems, that is skid type CIP systems, single pass type versus multi-use systems, central type CIP systems?
From the equipment side, again, this is it goes to, it depends. It depends on your application on it. When we talk multi-use, it's often a sustainability type of thing. So if I have additional passes, am I reclaiming water? It saves to, overall environmental impact, but also cost to the company of like how much water usage and chemical usage they have to go through. So there's a drive to do that, but also now when I'm returning and stuff, I have to take enough care with the system. Like it's effectively product contact now because I am bringing it back through and distributing around and circulating in that way that I have to have that level of care to the equipment. And the needs for what you, whether it's a single tank or multi-tank, again, it's kind of a complexity of what we're all talking about on here. Am I reclaiming things? Do I have multiple chemical steps? Well, like what are the pieces that I need to do that? And also, what's my time delay on how I can heat up? Do I have to store enough hot here to do a continuous flush, or can I do this all in one pass? And those kind of elements.
That's great. A question on reclaiming. What analysis should be done on the recovered CIP liquids to ensure that they are clean and chemically effective? I assume there are limits for solids, etc., and not infinitely reusable.
Yeah, that's correct. There are definitely going to be some limits. And when you think about the detergent selection being, is it an acid, is it an alkaline? We're really talking a little bit about electron potential there, right? So are we giving up electrons or are we taking in electrons based on where we are in the pH scale? And so you can literally use conductivity meters to assess where you are with respect to the target for that particular detergent. And as you are having chemical interactions through the scrubbing and through the different dissolving of compounds, that conductivity will change. And you can have an automated meter that doses additional chemistry into the line as needed. In terms of solids and fouling, there are ways to screen some of that out, but the efficacy does not continue indefinitely. So the chemistry does get used up, so to speak, and we have to keep an eye on that. It's important to have not just the forward flow, but the return lines monitored. And so we want to make sure to have a comprehensive look at that and to keep an eye on it so everything is within acceptable ranges.
Awesome. Thank you. Once I've decided to pursue a CIP solution, how do I start? Who do I call? And where do we go?
Yeah. Any of us?
I can think of 3 phone calls right off the bat.
I feel like it depends on a little bit of like where you're starting from, because Craig gave the example of I have specific regulatory pieces that I'm monitoring, and so
Right.
he's often approaching this much more from like the automation side. I'm from the more OEM equipment side, where sometimes like I have a physical need of like what I'm doing, like I know how large the wash is and do that. In the end, we're all kind of tying together and working off of this. But if you approach any of us that are making in that CIP area, I feel like we're all going to kind of come together. And there's some specialties, like areas like that I'll focus on, that or Craig focuses on, and so we're all of the understanding that there's different markets that we serve, and we know how to connect people, even if it isn't the perfect match for us.
And Austin, just if I can weigh in on that a little bit, Viking. I'm not sure if this helps a lot or not, but there's some really small CIP systems that folks on this call would just go and source themselves, probably online, and might be $5,000 to $20,000 capex investment. Typically, like where we start to get involved at Craft is in what I'm going to call the mid-size. So there's a protein powder group I'm working with now that's looking for a $35,000 to $70,000 CIP system for their equipment specifically to bring out to some of their customers. And I would call those mid-size. Those typically do have, in my case, have controls and reporting and things like that they want to include. And then the larger ones, I'm going to say, are going to be $100,000 plus. So depending on where you fit into that spectrum might get you calling different people, but certainly any one of us on this call can at least point you in the right direction. to who to call if there's something we're not sure of. We'd hand you over to Jason or Eric or vice versa, I'm sure. But that's a
Well,
good way
and to kind of piggyback off of the concept of the different scale of operations, when you have someone who's new to market, they've got a plant that has not really been in operation very long. Maybe their systems are quite small in terms of volume. It, it's something that we see when we do plant visits and audits and things like that. You're going to see the systems that are kind of cobbled together. Oh, well, hey, I have a balance tank here and a centrifugal pump, and I'm hooking it up, and I'm going to do a recirculating clean and hope for the best. Well, when you have that, oftentimes they're not measuring flow rate per pipe diameter. They're not capturing, uh, the conductivity on the return leg. They're not even sometimes capturing temperature, and so it's not often going to be a true CIP, because a true CIP, you're going to know the condition of each of those four pillars all the time. And so that it does require a little bit of build and a little bit of planning to make sure that the pump is positioned in an ideal location, so you're not losing a bunch of energy through fluid friction in these long horizontal spans. I mean, just simple things like that. You can design the skid one time instead of trying to put it together every single day after the end of the production run. So that consistency and those things that we talked about earlier, some of that comes even with the small scale CIP system. So just be careful when you're doing it just from scratch with the things that you happen to have around the facility.
That's great. Another question here. What are the main factors that affect the price of systems? Is it mainly capacity?
Capacity is a big factor because that's going to set the size of like heat exchangers and pumps and those kind of main hardware. But they also, you want to look at capacity of like hold volume, like the tanks that it's going to need, and that can often depend on how far am I running and like what am I cleaning. I need a certain volume to accumulate, and this can also tie into like what you have available for your utilities. Sometimes people don't have as much steam boiler as they think they do, and they end up needing to have an extra like hot water hold that goes to it, and like that expands the cost. A lot of that storage and that metal adds up. Those are probably the first pieces that go into it. And then I guess, I don't know if Craig, if you want to add to like the complexity of automation of depending on
Right.
there, that can also add your next layer.
Yeah, 100%. And it's funny because there's so many pieces that can go into it. We were working with a material handling company, and then where they put their equipment, the size of the doors, they wanted it actually on wheels, and it was a 2-tank, about 150-gallon CIP system. So it was going to be about $50,000-$60,000. But then they found out that several of their customers didn't have the doors to get it through. So we had to set up the P&ID to be able to get through certain doorways. That ended up being a customized product. We use the base and then we try to custom it down to save costs, etc. And then like the level of reporting that you need. Some companies are okay with, we're pretty good with still wearing, bringing manual pads with them and writing down results. Others, typically these days, they want to get an actual report of what was done. So when the swabbing is done for a given experience, they can trace it back to whether, that could have been related to too short of a cleaning period, or the chemical water ratio wasn't done correctly, whatever it might be. And that's a good reason for when you need to use a SCADA system to come in and get that reporting and transparency.
Great, thank you. We've got about 10 minutes left. I've got a couple more questions here. If you'd like to ask a question, please do so on the chat. When do you use a SCAD or SCADA system?
Yeah, so that's what I was mentioning just earlier. Typically, that's being driven primarily by the need for transparency and reporting. And depending on the needs, we're seeing it more and more, obviously, for what we do. It's a big part of what we do. If you don't require that reporting, or you don't need as much HMI and you want to have more of a manual approach, you're probably not going to be working with a craft automation. It's a lesser need. But the reason why we've been getting so many people interested is that's something that's going in the exact opposite. People want SCADA for transparency and reporting. And that's ultimately what we got to make sure is included in the programming.
What is the definition of SCADA? SCADA. What is the acronym? What does it stand for?
It's oh boy, I always like this one. Um, Let me see if I have it written down. Because I always forget. It's always
Just
like it's
supervisor
super.
control and data
Yeah, yeah,
acquisition. I had to look it up, I'll confess, but yeah, because we call it SCADA so often that
yeah. It's supervisor logics reports, something like that.
Okay, great. No, we got it. What is AI being utilized within CIP now that AI is pretty much part of everyday life?
I do know of some instances where larger systems are doing tremendous amount of data collection. And so as the CIP cycles are running over time, you get these data sets, and there can be some predictive analysis in terms of things like how much torque is being applied as a motor is running on a pump, or how what is the anticipated replacement schedule for different gaskets or maintenance parts, and are we on track to meet that schedule or come in long or come in short. So there are some things that predictive analysis can help with. Some of it is going to be really dependent upon the product mix. So if we're running, let's say we're running something that has a lot of gums and a lot of thickening agents, that's going to be a different cleaning ask than something that is very, very thin, right? Running through, or even looking at things like uh, beer systems versus milk systems, things like that. So looking at the different process and product parameters and making sure that the data set is bearing that in mind, so to speak, when the AI is doing the analysis, that's really, really important, because the predictive analytics are going to be based on past data. And so if you make changes to the product mix, or to the length of the run, or to any number of other things moving forward, then those predictions aren't going to be as on target as what they could be. But if you have a very consistent operation, you're running the same product over and over and over and over in the same, production run times and the same conditions over and over and over, you get those data sets, you can get predictive analytics out of those. So I hate to say it depends, but it really does depend on the production planning with respect to the existing data set.
Yeah, well, I think that I think one of many of the answers today is that there have been a lot of depends, because of size, what are we cleaning? What are the size of the tanks? And even when we said that, it can be under $30,000 for a CIP system, well into, massive investments, you think about these large breweries that have to clean all those tanks and vessels. So I think that's great, and I appreciate it. I have had a bunch of questions about if this presentation is available. Just so you all know, there is a response in the chat that all FPSA members will have access to the resources, and if you're not a member, it's the perfect time to join. Any closing thoughts, Craig, Jason, Eric?
I'll just there's any other questions, or I would suggest in any of the follow-up that FPSA, if there's more areas that we want to go more detail on, or something else that we missed today, that type of feedback helps FPSA a ton in terms of future webinars, and it helps us as panelists know what we need to prepare for.
Right. And I think continuing this conversation in subsequent events is going to be really useful, particularly if there's interest around that, because all of this is going to be contributing towards elevating your operational efficiency and elevating your food safety, frankly. So I think all of us, in a lot of ways, are just food safety advocates and operational efficiency guys, and we want to see you guys succeed. We want to see all the participants thrive. So whatever we can do to help those outcomes, I think everybody in the panel is on board with that.
Terrific. Thank you. I do want to say on behalf of FPSA, Craig, Jason, Eric, and a shout out to Michael Mass, who did a bunch of work on this as well, who couldn't be here. But thank you for the great content, great webinar today. Would like to thank all the attendees for coming and providing some great questions. And we look forward to the next time we meet at another FPSA webinar. Thanks, everybody.
Thank you.
Thank you all.